grade 11, grade 12, I welcome you to today's lesson. In the previous lesson, we were looking at a component method. We have learned how to calculate the x component and also the y component. In today's lesson, we are going to look at vector addition using components. So I want us to use this example to learn how vectors are added using components. Let's look at the diagram that I've put for you there. You can see that I have a Cartesian plane. We have y and x. And there are three vectors that are drawn on this Cartesian plane. We have vector P of magnitude 500 Newton. We have vector Q, magnitude 200 Newton. And we have vector R of magnitude 300 Newton. So, if we are reading the degrees around this Cartesian plane from this point here, for sure it will be 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, which is our revolution. This vector Q, if I'm taking it from positive x direction, is at 30 degrees. The angle between the x-axis and the vector Q is 30 degrees, because here is 0 going up, then 10, not 10, 90, 180, 270, 360. So if I'm taking it again from here, vector P will be 80. Vector P will be 80, because if here is 0 and here is 90, and we are given that from Y to point P, from y-axis to vector P is 10. It means that from P to X, from P to X is 80. Is 80 degrees, because from X to Y is 90. Is 90. And we are given that from y-axis to P is 10. From P to X is 80. If you combine these two, they'll give you 90. Now, let's come to vector R. In this one, we are given that is 16. You can take it from here. You can take it from here up to this point. From this x-axis here up to R is 60. Now, what is it that one must do in order to answer this question? In this question, we are required to determine the magnitude and the direction of the resultant force. We are required to determine the magnitude and direction of the resultant force. For us to be able to get the magnitude of the resultant force, we need the x component and the y component. Let me bring the previous page here to show you what they mean by that. Here is the page from the previous lesson. The question requires us to find the size of R. For us to be able to find the size of R, we need x component and y component. That's why it will be possible for us to then use the theorem of Pythagoras. So we have to do the same here. So the problem now is that we are given 3 vectors. Unlike here, where one can say we have the R component, Rx component, and Ry component only. We only have, if I'm talking about vectors, I can say this is vector Rx and this one is vector Ry. So in this one is very simple to get the R. But in this case, we have 1, 2, 3 vectors. So the easiest way to answer this question, we must do the following. We must first look for, I'm naming it here fx. We must first look for the x component. I just named it f. We must look for, or we must first look for fx, which is our x component. It means that we must look for the x component of vector p and x component of vector q and x component of vector r. So how do we get the x component of vector p? Here is p. Yes, p. Let me construct a right-angled triangle using the p as the resultant. This will be my x component going up. This will be my y component of p. X component of p, y component of p. Now, bring the formulas to enable us to move forward. Here, the formula which will make it possible for me to calculate px, which is the x component of p, is this one, p cos 80. This is the 80 between the x-axis and vector p. We said is 80. So is p cos 80. This x component that we're looking for is adjacent to this angle. That's why it contains cos. Is p cos 80. We write plus. We are moving on to the next vector. And then in this vector again, we will calculate the x component of this vector. If I have to put the triangle, it will go like this. A right angle triangle will go like this. This is my QX, and going up here, this will be my QY. But for now, we are looking for QX. We are looking for QX. The formula for calculating QX will be Q, because this QX is adjacent to the angle, it will be a QX equals to Q cos 30. QX equals to Q cos 30. Let me put it here. QX equals to Q cos 30. Then we have managed to put the formula for P, which is P cos 80. P cos 80, because this angle 80 is adjacent to PX. That's why we have this. And we also managed to get the formula for calculating QX. This QX is adjacent to 30. Again, it will contain cos, Q cos 30. Now we are moving on to vector R. Let me do the same with vector R here, trying to draw a right angle triangle. We already have X here. We have resultant R. Now if I do this, this becomes my RY. This is my RX. Now, what we want here is the formula for calculating RX. The formula for calculating Rx will be R cos 60. R cos 60, it is R cos 60. R cos 60. You can see that now I have included a negative sign. If the vector is pointing to the left, like this one, if the vector, or if the, not the vector, if the component that we are looking for is pointing to the left, it will carry a negative sign. And if the component that we're looking for is pointing to the right, it will carry a positive sign, like what had happened for this PX and QX. They are pointing to the right. That's why they're positive. Then RX is pointing to the left. RX is pointing to the left. That's why it is carrying a negative sign. Now, the next step, we put the values of P, Q, and R. That's why you can see that we have 500 cos 80 plus 200 cos 30 minus 300 cos 60. The next step, we use the calculator. You press 500 cos 80 plus 200 cos 30 minus 300 cos 60. This will give you 110.03 Newton. Remember, here we were looking for the X component, and then we have calculated the X component of P, X component of Q, and X component of R. Then we find the sum of all the X components. Here is the sum of X components, which becomes our Fx. Now, we must look for the Y component. we must look for the y component. We'll go back to the Cartesian plane, P, Q, R. This is the y component of P. This is the y component of Q. This is the y component of R. Then, what is the formula of calculating the y component of P? For sure, this time it will contain what? It will contain sine, because this side is opposite to this angle, 80 degrees. That's why here you can see that we now have P sine 80 degrees plus. We go to Q. This side, QY, is opposite to the angle, which is angle 30 degrees. So the formula will contain sine. That's why you can see Q sine 30 degrees. Then coming to this one, now you can see that this is the y component. This side is opposite to the angle. Again, it will contain sine. That's why we have r sine 30. Now, the issue of a sine is with us again here. What had happened? Why are we putting the negative sign here? This y is pointing down. This y is pointing down like this. You can see that my rx is pointing to the left. My ry is pointing vertically downwards. That's why it is carrying a negative sign. If you come to P, for Py, it is pointing up here. The Px pointing to the right, and then the Py pointing vertical upward. That's why it's carrying a positive sign. Let's come to Q. It is carrying positive. The Qx is pointing to the right, whereas the Qy is pointing vertically upward. So we then bring the calculator and find the sum of the y component of P, Q, and R. If you press it correctly, the answer will be 332.60 Newton. Now we have our x component, the sum of the x component and the sum of the y component. We now use the theorem of Pythagoras, because we are working with a right-angled triangle. You can see I've just put this here. Fx, the fx that I got here is positive. It will point to the positive x direction. Using a head to tail method, I have to put the y. This is the x pointing to the positive x direction, and then this is the y, which is positive, is pointing to the positive y direction. The resultant that I'm looking for is this one, FR. And remember, I'm not only looking for the magnitude of this resultant. I'm also asked to calculate the direction. But let's first calculate the size of this resultant. I already said that we will use the theorem of Pythagoras. In this case, fr squared, which is the resultant, equals to fx squared, which is the x component, plus fy squared, which is the y component. We have fx component, which is 110.03. Here I've put it. And then fy component, which is 332.60. I've put it here. Then we use our calculator. The final answer will be 350.33 Newton. So you can confirm this using your calculator, and see if we'll arrive to the same answer. This is the resultant force that we are required to calculate. The second one requires us to calculate the direction of this resultant force. We want the direction. We want the direction of this resultant force. For us to be able to get the direction of this resultant force, we must find theta, this angle here. It will tell us the direction of this resultant force. So, what is it that we already know? We know our adjacent side and we know our opposite side here. So, which means that the ratio that we're going to use is tan theta. We will use our ratio, which is, or our trig ratio, which is sine theta, not sine theta, but tan theta. So tan theta equals to opposite over adjacent. Tan theta equals to opposite over adjacent. Do we have the value of the opposite, which is Fy? Yes, it's 332,60. And then the value of Fx is 110,03. Then we use our calculator. In this calculator, what one must do is the following. So you must familiarize yourself with your calculator. If you are using a sharp like this one, when calculating the direction, you do the following. You will press second function. You'll press second function. Second function is here. Second function, you press tan. You press tan. You press open bracket. You press 332,60 close bracket. You divide by, you open bracket, 110,03 close bracket, then equals to, you will get the following. Let me see. Things are not working well here. Okay, let me check if I set it properly here, because it must be in degree. Yes, it is. Or let me leave that way of calculating and come and do it in this way. I think this one will be very simple. You press 332,60 divide by 110,03 equals to, you get this number. You copy the whole number down. You copy the whole number down. Do not be lazy. Let me copy it here. It's 3,022811 and then 96. This is the number that I got here. Then you come and do the following. You come and do the following. You press second function. Second function is there. Second function, you press tan. Then you press the whole number. 3,02281196, then equals to. You see, we get 71,694,86546. You can see that here I've written my answer as 71,694,86546. 7 degrees because I just took one number after the comma. So it is advisable not to do the shortcuts when doing calculations like this. So do this by yourself and see if you can get it right.